Hello friends. In the last lectures, you have learned about the operators, some of the primary operators, that is addition, subtraction, multiplication, division, and so on. And now you also know about the variables. So let us practice some more problems. So here, the first problem is conversion uh, from Fahrenheit to Celsius temperature. So there is one advice that never ever directly jump to the editor and write the program. First, try to understand on a piece of paper that what has been given and what is required. So in this particular problem, the temperature in Fahrenheit is given. You are expected to convert it into Celsius. Now think, what is the equation? So the equation is 5 by 9 degree Fahrenheit minus 32. So this is the input, this is the output. And once you do this, you will be getting the answer. So let us now move to the program. So here I'll be using two variables, that is C and F for Celsius and floats, and let us ask the user uh, enter temperature in Fahrenheit, and then scanf. This is Fahrenheit is in uh, float, so we will be using percentage F, so at the address of F. That's it. Now the equation part, that is Celsius, is equal to 5 by 9. I am doing something wrong here. So let us see what wrong is and what output it will give. So it is this into F minus 32, and then print the Celsius. Printf what this much Fahrenheit is equal to this much Celsius, and this is F, and this is C, and then run it. So let's say 100 degree Fahrenheit. So it is saying that 100 degree Fahrenheit is 0 degree Celsius. It is wrong. So what is wrong? This is wrong. Here integer division we have done. We should not do this because integer division return integer only. So we should either typecast it or make one of the numbers as float. Then it will be okay. So if it is 100, now it is giving me 37.77. So you can also restrict the number of precisions. Let's say 3 only. So it is 100. Now it is 100 Fahrenheit is 37.778 Celsius. Then comes the second problem. Forget about the centroid and moment of inertia part right now, because later on we will be doing n number of problems from the core engineering sector. So it is saying that radius is given to you. Let's say the radius is 0.1 meter, and you have been asked to find out the area in perimeter. So you know area is pi r square and the perimeter is 2 pi r. So in this will be your input and these will be your output. Apart from this, you have to also define pi. There is uh, for such constants you can always use hash define to define the variables, like sort of the variables which are going to be constant throughout, or some constant if you want to define. So you can do what? You can define and then write the name pi and then give 3.14. Okay, now in this program, area and perimeter are required and radius is given. So we'll be modifying like area and peri. So area is the area, peri means perimeter, r is the radius. So enter the radius, enter r. So this will be getting transferred to the memory location of r, and then we'll be evaluating area and perimeter. So area will be equal to pi into r square. So r into r, and then perimeter is going to be 2 into pi into r. Okay. Now area and perimeter you have evaluated. Now you can simply say area is equal to this. So this is area, and likewise you can also say perimeter in the next line. Copy it, come to the next line. So this is perimeter, and this variable name is also peri. Run it. So let's say radius is 0.1, so area is 0.031 and 0.628. So being engineers, you should always be giving units. So this much meter square and this much meter. So 0.1, so this much meter square and this much meter. So in this way you can solve your problem. And then comes the last problem, that is this one, capillary action. So for capillary action, the rise in capillary, what is this? When you dip a capillary in, let's say, water, so due to surface tension it will rise. So how much capillary has moved up from that particular datum? It's h. So its formula is 4 sigma cos theta by rho gd, where sigma is the surface tension, rho is the density, g is the gravity, d is the diameter of this capillary tube, and theta is the contact angle there, this theta. So now as you are using, as you require theta to be evaluated, so you should be using library math.h, because this is the library where the information of all the trigonometric function and other mathematical functions is kept. So let us write it quickly. So here I have already included math.h. Okay, so now uh, sigma, and then let us give the value here itself. So let's say sigma is 0.1 and the diameter of the tube is it is 0.01. Diameter of the tube is 0.01 meter, and then comes the acceleration due to gravity, that is, you can also define gravity there. So hash define g as 9.81. Okay, so 4 sigma cos theta by rho gd. So rho it is water, so let us take 1000. Then theta, so let's say that it is 0 right now. So 4 sigma is there, cos theta is there, by rho g is there, and d, everything is known to me. Now h, that is the capillary rise. So the formula for h, so as already all the informations are there in the code itself, so we didn't have to apply anything from the keyboard. So simply evaluate h. It is 4 sigma cos theta by rho g and d. Now there is one problem. As you all know that the trigonometric function accepts arguments in radian. So you have to convert this theta into radian. So theta is equal to, so theta is equal to theta into pi divided by 180. Okay. So this is theta, this is theta. Once this is done, so the program is almost over. Now this is your h, that is capillary rise, and here we require the value of h only, so it will be coming in meters. So let us run it. So we are getting 0.000454 meter. Now in engineering we never write like this, we always use the exponent form. So instead of percentage f, you can use e for exponent form. So now it is 4.5 into this. Now again, here let's say I only want two places after decimal. Okay, so total let's say 5 I will require, and two places after five five numbers will be there and two numbers will be after decimal. So this will be 4.54. So there are only three, 4, 5 and 4. What about 5? So rest is there in front. Okay, one is for sign, one is kept as such, and then in this way it can be printed in exponent form. So apart from this, there's one more thing you should know, that whenever you require something raised to the power something, so there's a function whenever you want to do this. Let's say a to the power b. In previous problem of area, it was easy because there is only r into r. But let's say in some problem it is r to the power 1 by 7, r to the power 10, then it will be very difficult for you to write. Then there is a function known as POW, which will raise a to the power b. Okay, and this is there in the math.h library. So from next time, whenever I will be getting this exponent form, that is a raised to the power b, I will be using this. So if I want to do, let's say 2 to the power 5, then its expression should be POW 2 raised to the power 5. That's it. So this you should understand. Okay. So in this video, till this point only, thank you very much for watching it. And in the next video, first we'll be discussing about increment and decrement operator and how they are working. And then we'll be writing a code or few codes for understanding, and then we'll be jumping in the next video in the decisions, that is conditional operators. Before that, we'll be also discussing about the relational operators and that all. So in this video, till this point only, thank you very much for watching it.